Hi everybody, hope you all are doing okay. So the next topic we're going to talk about are logarithms. So I want you to know that I'm going to be using the same videos from here on out with both pre-calculus and algebra 2, and here is why. So logarithms are a very important concept, and if you are in my algebra 2 class, you'll be seeing this for the first time, learning it for the first time I should say, and then you will see this again in your future math classes. So if you're in my pre-calculus class, you learned this last year in Algebra 2, but I know it's been over a year ago and you probably forgot it and you need a refresher. So this is a refresher for you, new for Algebra 2. So no matter what math class you take next year, those of you who are in my pre-calc class, you'll need logarithms. So if you take honors calculus or AP calculus, you will need to know logs for sure. Even if you take stats or AP stats, logs are in there too. So it's a really important concept, and I want to be sure that you know them so that you're prepared for next year. So we're going to be doing logarithms with the rest of our time together. Okay, so let's get to it. So in our last lesson, we discussed exponential functions, and I want to explain that again real quick. So remember, exponential functions have this form: y equals b to the x, and b just represents the base of the function. So the b has to be a positive number and cannot be 0 either. So it can't be 0, can't be a negative. So when you studied inverses, so if you're in my Algebra 2 class, we did inverses very recently. If you are in my pre-calc class, we talked about inverses earlier on in the school year, probably the first quarter. But what you do to find the inverse of any function is you switch the x and the y. So if I were to do that here, I would have x equals b to the y. So when you switch the x and the y, then you are supposed to solve for y. Well, the problem is here that the variable that you want to solve for is in the exponent. So in order to solve for that number, you have to use what is called a logarithm. So the logarithm in math is abbreviated by log, and the logarithm will have a base, and it will be the same base as the exponential function. So that will be b, and it's written as a subscript, so it's a little bit lower than the g. And then the number over here will be the number that you take the log of, so that will be x. And then after the equal sign, that will be y. So notice that the y is isolated now, which is what you want to do when you find the inverse. So you may see it written in this form, or it could be switched around with the y here and then the log on the other side. But either way, this would be considered a logarithmic equation, and this is exponential. So what you have to do in the first example, the first two, is to switch back and forth from one form to the next. So let's go over that now. This is easy, but you have to kind of get the hang of going back and forth. Okay, so for 1a, the equation is 2 equals the log base 5 of 25. So listen to how I said that, because that was the proper way to say this. Log base 5 of 25. So you'll need to know that in the future. Okay, so this is considered a logarithmic equation. We want to change it to exponential. So it's like it currently looks like this form, and we want to switch it to this form. So it's all the same numbers, it's just has to be rearranged. So we want to put the x here, and the b here, and the y here. And then you got it. So notice that the base of the exponential is the same thing as the base here. So that means the 5 would be the base. The number on the opposite side of the equal sign, the y in either case, that's going to be the exponent. So that will be the 2. And then after the equal sign will be the number 25. So it's 5 squared equals 25. So these two mean the same thing. It's just that this is called logarithmic and that's called exponential. Okay, so let's do another one real quick. This is part B of number 1. So the equation looks almost the same. It's 3 equals log base 4 of 64. So the base is 4. It will be raised to the power of 3, and then that will equal this number over here, 64. So 4 cubed is 64. 4 cubed is 64 is the same thing as this logarithmic equation. And there's one more. Let's do C. So it's y equals log base 3 of 7. So the base will be the 3. I'm raising it to the power of y, and then you will get 7 as the answer. So all of these, all I've done is I've changed from this form back to this form. So you're changing a logarithmic equation to an exponential equation. So number 1 is complete. For number 2, we're going to go the opposite way. We're going to start with an exponential equation and change it to a log. So let's see, number 2a is 12 squared equals 144. So you want to think of it as this equation is the same thing as this. So we're just changing it to a log over here. So you're going to use a logarithm, abbreviated log. The base will be the 12. The number you're taking the log of is the 144. And the answer is the exponent, 2. So it's log base 12 of 144 is 2. That's how you would say it. So that's A. For B, this one is 2 cubed equals 8. That's the exponential equation. As a logarithm, you would write log. The base would be the 2. The 8 would be the number that you're taking the log of. And the exponent 3 is the answer. So you would read this log base 2 of 8 equals 3. And there's one more in number 2. 4 to the y power equals 9. You would rewrite that one as the logarithm with a base of 4 of the number 9 equals the exponent y. So those two things mean the same thing. So all we've done so far in 1 and 2 is just switch from one form to the other, which you will have to be able to do pretty well in future math classes. But now the real meat of logs is in the next section. It's of how to evaluate a log. Now you'll notice that some of these directions say that you have to evaluate with a calculator and some say without. Although I can't police whether you're using a calculator or not at home, I would ask that you really do try to do the ones that say no calculator without one, because you're going to run into this next year in your future math classes, and it would be better to just learn it now than to have to be struggling to learn it next year in the midst of other things that you're trying to learn. So it's always best to learn it when you're supposed to. So please pay attention to the directions and don't use a calculator when I say so. Okay, so for the first one, it says log base 7 of 49. So it's asking us to figure out what the answer to that is without a calculator. So here's how it will work. We're going to change this equation to exponential form and then figure out what the answer would be. So the base of this log is 7. We're going to raise it to a power. So I'm just going to pick a variable, say an x, and the answer must be 49. So you want to think 7 to what power would give me the answer 49? So if you think about it, 7 squared is 49. So the answer would just be 2. Your answer is going to be the exponent that you need to raise this number to a power to get this number. And that is all you are doing when you're evaluating a log, is figuring out what exponent is needed in each case. So we're going to do lots more examples. So look at B. Log base 3 of 81. So you're trying to think, if you took the number 3, can you raise it to a power and get 81 as the answer? Well, you might have to think a little harder on this one. But think 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 81. So that's 3 raised to the 4th power would be 81. So your answer would be 4. It's the exponent that you need to get this answer that you need. So 4 would be the answer for 3B. Okay, I'm going to erase these and keep going. Okay, let's look at C. So we've got log base 49 of 7. So if you compare this to number 1, the 49 and 7 are in opposite places. That means that it's something different. It's not going to be the same answer. So you want to think the base 49, what do you have to raise that to that will give you the answer 7? So this one is a little tricky because 49 is greater than 7. So that tells us that we need to think about this slightly differently. So how are 49 and 7 related to each other? Well, 49, if you took the square root of it, you would get 7. So think along those lines. The square root of 49 is 7. So every radical can be changed to what is called a rational exponent, which means an exponent that is a fraction. So if you're in my Algebra 2 class, we just studied rational exponents maybe like 2 weeks ago. If you're in my pre-calc class, you probably haven't seen this since last year, but it's going to come up again in your future math classes. So here's how it works. It's written as a fraction, and here's how the fraction goes. Think of 49 as 49 to the first power, and think of the square root as having a 2 here. Square implies 2. So it would be the same thing as 49 to the half power would be 7. So your answer for this one would be 1/2. So every square root can be thought of as a 1/2 power. So let's think about some other ones because they will come up in the future. So like for instance, the one we just did. If you do the square root of x, that's the same thing as x to the half power. If you ever see a cube root of x, that would be x to the 1/3 power. And if you see the fourth root of x, that would be x to the 1/4 power, and so on. That would continue on. So every radical can be rewritten as an exponent that is a fraction. That's called a rational exponent. So that will come up again in your future math classes. Okay, so let's move along to D. What is that one? We have log base 6 of 1/36. Okay, so this time we have a fraction that we're looking at. All fractions can also be rewritten as exponents that are negative. So we're going to think along those lines in this problem. So we're trying to still think 6 raised to what power is 1/36. Well, keep in mind that 36 would be 6 squared. So that would be like 1/6 squared. And you learned in algebra that a negative exponent is used in this case. So this would be the same thing as 6 to the -2 power. So any exponent that's in the denominator can be rewritten as a negative number. So that would mean that -2 is your answer for part D. And there's one more in the section, part E. We have log base 2, and this is the 5th root of 2. So as I was saying in the example before, this was part C, you can think of any radical as an exponent. So it would be the same thing as log base 2 of 2 to the 1/5 power. 5th root implies 1/2. So you're trying to think 2 raised to what power would be 2 to the 1/5 power. So of course that means the answer is 1/5. Okay, so that's how you would do all of the ones that say evaluate these without a calculator. You would think of the exponent that is needed to take your base and raise it to that number to get the other number. Okay, so let's go on to the next section. So there are 2 special types of logs that we're going to look at. So one is called a common log. So a common log has a base of 10. So you will never see a logarithm with a little 10 there as the base. That's not how it's shown. All you will see is just the word log with nothing written for the base. So in the future, if you ever see a log with no base, you'll need to know that that is a base of 10. So you would still be able to solve some of them without a calculator. So we're going to go over those now. So let's take a look at 4a. So the first one says find the log of 100. We can do this without a calculator. So if you think of this base, if nothing's written, that's a 10. So you're trying to think of 10 raised to what power would give me the number 100. So of course 10 squared is 100. So the answer would be just 2. How about b? b is the log of 10. So if there's no base, remember that's a 10. So we're trying to think of what power of 10 would give us 10. Well, 10 to the first power is 10. So that means our answer is just 1. Part C, if you notice, is a decimal. It's 0.0001. So for this one, it would help you to think about scientific notation. We've done it a little bit in this class, and I'm sure you've seen it in science where you write a decimal and it's like times 10 to the negative whatever power. So it's the same concept here. We're trying to think of 10 raised to what power will give us this number, 0.0001. So it has to do with moving the decimal point and how many times you move it. So since this is a smaller number, it means that the exponent will be negative. So you want to count how many times the decimal would be moved. So think of the decimal being here. If I go 1, 2, 3, 4, that would mean it's 10 to the negative 4 power. Is the same thing. So your answer for the problem is just negative 4. So all you're doing is counting how many times you would need to move the decimal and make it a negative number. So it would be negative 4. And the last one in that section is an easy one. It is the log of, let's see what number that is, 1 million. Okay, so you're trying to figure out what base of 10 would give you 1 million. Well, just think about this. 10 to the first power would be 10. 10 squared would be 100. 10 cubed would be 1,000. 10 to the fourth would be 10,000. 10 to the fifth would be 100,000. And then 10 to the sixth will be 1 million. So your answer is just 6. Okay, so that's how you would do common logs with a base of 10 without a calculator. So there are some times when you will need a calculator, and I'm going to show you those next. So for instance, the number 5a, get my paper closer, it says find the log of 142. So without a base, that means that's a 10. So you're trying to think 10 raised to what power is 142. Well, the problem is it's not a whole number, because 10 squared would be 100 and 10 cubed would be 1,000. So it means it's somewhere in between 2 and 3. But there's no way we're going to just in our minds know what that number is. We just know that it's got to be somewhere in between 2 and 3. So the calculator will do this for us. So I want to go to the calculator now. So get yours out and I'll show you how this all works. It's easy. So going to your calculator, go over here. Let me get out of this. Okay, so on your calculator screen, there is a log button. It's right beside the number 7. It just says LOG, that's the one. So you would press that. You would put in the number that we were given, which is 142, and we press enter. And then this would be your answer. I'm going to ask you to round to the thousandths place. So I would say that that is 2.152. Now I don't want you to just press buttons on the calculator and not understand what you're doing. That's never a good thing. So I want to remind you that when you find a logarithm, you're figuring out what base of 10 will give you the number that you started with. So try it. If I took 10 and raised it to the power of this number, I should have the number I started with. Now, rather than rounding this number or even typing it all in, that still would be rounded, I want to just use the entire answer. So I think I've showed you this before, but you would press second, and then answer is with the negative key at the bottom of the calculator. So it's going to say ANS, that's second answer. So when you press enter, notice it's 142. So that's what the calculator is doing for you. It's figuring out what power of 10 gives you the number that you started with. So put down for 5A, 2.152. Okay, so for B, it's the log of 8. So you would put the log 8, and that's it. And you would get this number rounded to the thousands place would be 0.903. So that's your answer. But I want you to understand what it means. So it would be 10 raised to the power of that number. So put in answer, and you would get 8, the original number. Okay, and the last one in this section says find the log of 3,476. And you will find that to be this number. And rounded to the thousands place, I would say that's 3.541. So what that means is if you raise the number 10 to the power of that answer, you would get the original number, 3,476. Okay, so that's part number 5. So the important thing to know is that this log button that we just used is only used for base of 10. That's a common logarithm. You cannot use it for any other base. So if you look at number 6 coming up, notice that all the things that they're asking you for do not have a base of 10. They have a base of 3 or 5 or 6 or other numbers. So I'm going to show you now what to do when that comes up. So the first one says log base 3 of 34. So you're trying to figure out 3 raised to what power will be 34. You're not going to be able to do that in your head. The calculator will have to tell you. So let's get out of all this. Okay, so some of you have the exact same calculator as I do, and some of you do not. So I'm going to show you both ways so you'll know exactly what needs to be done on your calculator. So if you know your calculator has been like mine all year, this is what you'll do. You'll go to math. You want to arrow all the way down, even past all the stuff that you see. There's still more things down there. So it would look like this, log base. If your calculator has that, go ahead and use it. So if you press enter, you'll see that it brings up this log, and you can just fill in the numbers. So our numbers were, what was it, 3 for the base, and then over here, 34, and then you get this answer. Okay, you'll be asked to round to the thousands place, so you would put 3.210 as your answer. Now keep in mind, that means if you took the base of 3, raised it to that answer, you would get the answer 34, the original number. That's what the logarithm is doing for you. Okay, so some of you probably do not have that option when you press math. Your calculator might be a different version than mine. If that is the case, you're going to do what is called a change of base formula. It's not difficult, but it's just another way that you'll have to do it. So the formula is on your paper, but I'm going to show it to you right now. It's not hard. You're going to use the common log button, the one we used earlier. You're going to put the number 34 inside. You're going to close the parentheses, and then you're going to divide by the common log of the base, which is 3. And then if you do that, notice you get exactly the same answer. So if your calculator doesn't have that log base button, don't worry. You'll just have to enter it like this. You'll get the same answer as everybody else. And if you still do the same thing, like 3 raised to the answer, you're still going to get 34. So no matter what, you'll be able to get the answer. Your calculator just might be a little bit different. Okay, so let's do a couple more of those. The next one is log base 5 of 162. So we go to math, we arrow down to log base. I'm putting the 5 as the base and 162. And enter. So we get this, and you should round it to 3.161. We'll go with the thousands place. So that means raising 5 to the power of that answer should give us the original number, and notice it does. Okay, so if your calculator is a little different, use the common log of 162 divided by the common log of 5. And you'll get the same thing, should be. Yep, there it is. Alrighty, and one more. We've got the log base again on some calculators. And we got the log base 6 of 210. And it equals this number. So rounded would be 2.984. So if your calculator is different, you could do the common log of 210 divided by the common log of 6. And you should still get the same thing. Alrighty, so that's what you will do if the base is something other than 10. So there's another type of special log called a natural log. So a natural log has a base that is e. And remember in the last lesson, e is the natural base e, also called the Euler number after its discoverer, and it's equal to a number that is approximately 2.71828 and so on. Remember, it's an irrational number that continues indefinitely and does not repeat, but it's approximately 2.718. So whenever you see a logarithm with a base of e, you won't see it like the word log with a little e in the subscript. You'll see ln for natural log. Now you might be thinking, and I know many students do, why in the world do they say ln instead of nl? Well, I got the answer for you if you care. So if any of you study Latin, the Latin name is Logarithmus naturali. So logarithmus naturali is the word, so that puts the L first and then the N. So that's why it has to do with Latin. So it's ln. So there is an ln button on your calculator. It is right underneath the common log, so right beside the number 4, that's the one, ln. So if you look at number 7, they want us to find the natural log of 35. So you would just press ln 35, and you would get this answer. So rounded, you would say that's 3.555. Now I want you to understand again what this means. So it means that you want to take the answer, the number, e, and raise it to that power. So I showed you this in the last video. You would press second ln, that gives you e where you can raise it to a power. Then you go to answer. So e raised to that answer is 35. So it works the same way as the other logs. It's just that e is the base rather than a 10 or any other number. It's e. Okay, so that's the first one. Now we want the natural log of 1.5. And that gives us this answer, 0.405 rounded. And remember that means if you took the base of e and raised it to the answer, you would get 1.5. And one more in this section, the natural log of 426 is this number, 6.054. So if you took e and raised it to that answer, you would get 426, the number we started with. Okay, so notice on the next several questions it asks us to find natural logs without a calculator. So there are a few natural logs that you would be able to do without a calculator, and this is stuff, like I mentioned, you're going to see again in higher math classes. So if you look at 8a, it gives you the natural log of e. So if you were asked to do this without a calculator, you'd have to remember that a natural log has a base of e. So you would be trying to figure out what exponent you could take it to that would give you the answer e. Well, keep in mind that e to the first power would be e, so that means your answer is just 1. B, natural log of 1. Remember, natural log means a base of e. So e raised to what power would be 1. So in algebra, you studied exponential rules. This is algebra 1. And you learn that any number to the 0 power would be 1. So that is the case here. E to the 0 would be 1. So your answer is 0. And then there's one more example, natural log e to the 4th power. You would be figuring out what power of e would give you e to the 4th. So of course that would be 4, the exponent. So some of them you can do without a calculator if they are of this type. Now the last section lets you know that you cannot do the logarithm of 0 or any negative number. So if you do, I want you to see what happens. So one more time to the calculator, and I know this video is long and I'm really sorry, but logarithms are super important and you will definitely see them again. And I want to make sure that you understand them and you're not just randomly pressing buttons on your calculator. So I'm really doing it hoping that you understand. Okay, so if you do the logarithm of 0, this is a common log. Here's what happens on your calculator. It says error domain. That value is not allowed. So you can't do the log of 0. The other thing is a negative number. So notice it says find the natural log of -3. Again, you're going to see an error, non-real answer. You cannot do the natural log of a negative. Or if you do a common log, do a common log of a negative number, like the -1/3 on the next one, you're going to get an error. That means that's not allowed. And the last one, a natural log of 0, can't do that either. So anytime you try to take the log of a negative number or of 0, you're going to get an error of some type, and that means it's not possible. So for all of those, you would put that it's undefined or not possible. All right, y'all, so sorry I took so long, but logs really are important, and I hope you appreciated it. I love you guys. I'll talk to you later. Bye-bye.